Hello friends. So in the last lecture, we have studied speed control of slip ring induction motor, and we have studied how the speed of a slip ring induction motor can be changed by changing the rotor resistance. Uh, so we observed that by increasing rotor resistance, the speed can be changed, but the efficiency of the drive will reduce because there will be higher I square R loss. So also, it is difficult to just keep on varying the rotor resistances uh, in the slip ring through the slip ring. So, a new method that came into being due to advancement of power electronics. So, through power electronics, we can have a variable resistance control across the rotor winding. So, we can see that. So, I will just shift this and let us take a side by page. So so we can shift horizontally. Okay, there's some place remaining. Okay, so this will be your fifth one. So rotor resistance control through electronic. Electronic method. Okay, so we have got a symmetric. Let us say this is stator, this is our rotor. Okay, so we are feeding three phase supply on the stator, and there is three phase winding on the rotor. So we can include a three phase rectifier here, three phase, and that will be controlled rectifier. So what is controlled rectifier? Controlled rectifier, the output voltage can change. So there we can have a DC link capacitor, which will uh, mm, filter the rectified voltage, and we can insert here the resistance. Okay. Now, if we go on vary this output voltage as by changing the firing angle of this control rectifier, we can change the output DC voltage. So we can write it here V R, and this is external resistance which we have to insert. So now, as we change our VR, the power going into this resistance will change. So we are inserting we are extracting variable power from this rotor winding. Variable power means first this external resistance was included into this winding. It was this external resistance was directly connected to this rotor winding. Now this external resistance is being connected by this through this control rectifier. So the current and voltage in this resistance can be changed, and therefore the power can also be changed. So in a sense, it is variable resistance that we are inserting in this rotor winding. So through this powertronic circuit, we just need to uh, give this switching pulses. We just need to give uh, switching pulses. As you know, switching pulses to the switches present in this rectifier, which will vary the voltage and current in this rotor winding, in this external resistance. So this is how we can insert variable resistance to this rotor winding, and as per rotor resistance is changing, um, mm, the torque speed characteristic uh, of the this motor will be changed, as we discussed in last lecture. But now just let us not waste our power into this extra resistances. What we can do, we can remove this extra resistance. So let me do this. So we can remove this rotor extra resistances and just insert inverter here. You see, inverter that will generate voltage at that will generate three-phase power at constant voltage and supply frequency. So what we have done, uh, the power which was being lost in the extra resistances, now uh, we are taking that power and feeding it back to the supply. Now just we fed the power back to the supply. By through this inverter control, we can extract variable power from this rotor winding. So we need to control this inverter pulses, inverter control. So variable power will be extracted through inverter control. And this variable power is being extracted from this rotor winding, and we are feeding it back to the supply. So this is working similar to your rotor resistance control. Previously, we were inserting directly the rotor resistance into this rotor winding, so power was being lost in the rotor resistance, the extra resistances. Now the same power is being carried forward to the supply, so our power will be saved, and therefore the efficiency of the system will also increase. This method is called slip recovery method. Slip recovery method. So this is a slip recovery method is used for high rated induction motors. Uh, so by this your unit 8 is also complete. Unit 8 mostly comprised of your uh, speed control of slip ring induction motor, in which the effect of adding rotor resistance to torque slip characteristic is studied. Then the shift of operating point as per the shift of torque speed characteristic is also in your syllabus. Then this method, slip recovery method, the power electronics method of taking variable power from rotor resistance and do the speed control. All this is in your 8th unit. So now your only 7th unit is remaining, and some part of your 6th unit, that is vector control and direct vector torque control methods are remaining, which I will cover in subsequent lectures. Okay, thank you for now. There might be one more thing is there might be many doubts which you will have in this slip recovery method. So you should get it clear by asking them in the Google Classroom or YouTube, posting your comment in the YouTube video. So just do not hesitate and ask your query. Uh, that could be a personal mail or personal comment in the Google Classroom as well. So do not hesitate, ask your query. Okay, thank you.